Welcome back to another Algebra 1 lesson. Today we are doing 5.1. Lesson 5.1, solving systems of linear equations by graphing. Systems of linear equations is just multiple equations, multiple linear equations. Okay, today part of your assignment you're going to be handing in is a URL from Desmos. So first things is to make sure that you are logged into your account on Desmos so that you can save it and hand in a URL. Okay? Alright, let's look at our first problem here on page 5.1. We're on page 122. Write an equation that represents the costs. So, let's start off here. Your family opens a bed and breakfast. They spend $600 preparing a bedroom to rent. The cost to your family for food and utilities is $15 per night. They charge $17 per night to rent the bedroom. A, write an equation that represents the cost. Cost of dollars equals $50 per night times the night plus $600. So that's the initial cost to start this up. So how do we write that? Well, our cost equals $15 times your night plus $600. So there's our first equation, and we're going to plug that equation right here into Desmos. Y equals so we got our first equation in Desmos. Now, let's check out our second equation. Write an equation that represents the revenue. So, revenue equals $75 per night. So, the amount of money we make is $75 per night. Let's plug that equation into Desmos. Okay, so that's going to go way up there, so we're going to have to pan way out. So I have this blue line that's just hugging right here, and then we have this red line, and there we have our, where does it cross? Let's get in a little bit tighter. And so this system of equations appears as though it crosses right here, 747.50, and this is 10, so 10,750 right here. What is that point? 10,750. So what that tells us is 10,750 is the solution to this set of linear equations. And so how you're going to note that in, so this we're just going to, there you go. You can also, if you want to, you could just use this as notes. Oops, maybe it won't let me. I should have done that before. So that's our solution. What solution means to a system of linear equations, the solution is where two lines cross. That's the solution. Because this point, if we plug it into either equation, it will be a true statement. So if I plug in, so 750, if I plug it in for y, so 750 equals 75 times 10. Oh yeah, 750 equals 750. If I plug it in here, 750 equals 15 times 10, that's 150 plus 600. So 750 equals 750. This makes both of these true. It's the point where the lines cross. Okay, let's clear this out. We're going to go back. Okay. Alright, now we're back to semi-normalcy, and we are going to check this out. We're going to move to page 120, 123. I'm going to move to page 123, and we're going to go down to 4A right here. Solve each system by using a table or sketching a graph. Explain how you choose each method. Use a graphing calculator to check your solution. So what we're going to do is we're actually just going to check. We're going to see what a solution is for these. So I'm just going to plug this into Desmos. So let's go to Desmos. And I'm going to go y equals negative 4.3. X minus 1.3. And then the second equation is y equals 1.7 x plus 4.7. Alright, so now I have these two problems, and I want to know where they cross. So right here we have negative 1, 1, 2, 3. So they cross at negative 1, 3. Negative 1, 3. So what I'm going to do in order to, for my homework, is I will put negative 1, 3 as my answer for these two. Actually, I should put it at the end. Why does it keep going up there for my little note thing? So that's how it's going to look. I have my two equations, and then my solution. And again, if I plug this x value in for here, and this y value in for here, that will be a true statement. And if I plug the negative 1 in for x and the 3 in for y for this equation, it will make it a true statement, which just proves that that is a solution for those problems. Okay? And we can do that for any one of these problems. We can plug in b. Actually, let's do that. For your homework, since you're going to keep all of your equations on here, you're going to turn those white, and for b we have y equals x, and the second equation for b is y equals negative 3x, negative 3x plus 8. And the solution for that is going to be right here. 1, 2, 1, 2. It's going to be 2, 2. So your solution, meaning the point that would satisfy both equations, is right here where the lines cross. That is a point that is on both of those lines. So that's the solution for that. Alright, let's move on to page 124 and do some vocabulary. Don't forget, this has to be a part of your homework, so if you don't have the vocabulary in there, you don't get credit for your homework, so please include the vocabulary. Alright, a system of linear equations. That is simply two or more linear equations. That's it. A system of linear equations is simply two or more linear equations. How about a solution of a system of linear equations? A solution of a system. It's a solution that solves all equations in a system. This is a solution that solves all equations in the system. Solves all the all the equations. So how do we work with these? So solving a system of linear equations by graphing, which is what we've been using with the Desmos calculator. We graph the equation in the same coordinate plane, which means we're in two-dimensional, it's not three. So we graph each equation in the same coordinate plane, estimate the point of intersection, and then we check that point to see if it qualifies. So we check the point from step 2 by substituting for x and y in each equation of the original system. And I'll show you what that means to check. So if you go into your homework right now, page 125, start of your homework, what we have is a system of linear equations. There's one system, there's two different linear equations here. And what they're asking is this, is 3.1 a solution, is 3.1 a solution to both of these? How do we check? Well, we just plug it in and make sure you show your work. So 3 is my x value, so I have 3 plus 1 equals 4. 4 equals 4. Check. Now I plug these into here. 2 times 3 minus 1 equals 3. 6 minus 1 equals 3. 5 equals 3. So this is not a solution. This is not a solution. If both of these checked, if both of them were true, it would be a solution. But because one of them is not true, it's not a solution. Alright, go ahead and try number 2. See how you do. And then let's work on number 3. So go ahead and pause the video and do number 2. So is 2O a solution for this system of linear equations? So, excuse me, check number 1. So y equals x minus 2. So y is 0, so 0 equals 2 minus 2. 0 equals 0. So that first equation checks out. So I want to check this one. 0 equals negative 3 times 2 plus 6. Negative 6 plus 6. Negative 6 plus 6 is 0, so that checks out. So yes, a solution. So here we didn't get a solution, here we do have a solution. So do number 2, go ahead and move on to number 4, and I'll do number 5. So negative 2, 3 is our solution for this system of linear equations. Let's check. 3 times negative 2 minus 2 times 3 equals negative 12. Negative 6 minus 6 equals negative 12. Negative 12 equals negative 12. So that one checks out. Check. Checks out. So let's check the second one. So 2 times negative 2 plus 4 times 3 equals 9. So negative 4 plus 12 equals 9. Negative 4 and 12 is 8 equals 9. Not a solution. Now we can even check these too. If I were to go to Desmos calculator, I would see if I plugged in this equation and I plugged in this equation, I would see if this is where they cross. So let's check it out. So I'm going to blank those. Actually, these are examples, so I don't need these examples. So I'm going to plug in my new. So I have 3x minus 2y. 3x minus 2y equals negative 12. And then I have 2x plus 4y equals 9. So we're trying to see if they cross at negative 2, 3. 1, 2, 1, 2, 3. Oh my gosh, that is really close. But look, not quite. So here's negative 2, 3. It works for the black line, which we found out it was a check for the black line, but it does not work for the red line. So that is not a solution. That is not a solution for those. Okay. Now what if we have these graphs? How do we do this where they're already graphed out? Use the graph to solve the system of linear equation. Check your solution. Well, we simply go to where they cross, and that should be our solution. So negative 1, 2, 3. So negative 1, negative 3. Now, that's what I think it is, but it says we need to check our solution. How do we check our solution? We plug them back in. So x, which is negative 1 minus 2 times negative 3 equals 5. Negative 1 plus 6 equals 5. 5 equals 5, so that checks out. Now I'll go to the second one, 2x. So 2 times negative 1 plus a negative 3 equals negative 5. So I have negative 2 plus a minus is minus, or negative 5. Negative 5 equals negative 5. That checks out. So my answer was correct. Negative 1, 3 is a solution set, is a solution for this set of linear equations. All right, let's go now to the next page. Am I doing odds or evens? Evens. Okay. Wait a second. Oops. I skipped. I was doing odds, and then all of a sudden I skipped to evens. So shoot, now I can do whatever I want. Let's go for some evens. So here, what I would love for you to do is to draw it out here, but I'd like you to also check it on Desmos calculator. So this is where you're going to save your work from Desmos. So negative x plus 3, I go up to 3. My slope is down 1 over 1, down 1 over 1, down 1 over 1. So that's my slope. So I could draw this, and hopefully I will get a straight line. I do this one, x plus 5, so I go up to 5, up 1 over 1. Uh-oh, looks like I'm right in the middle here. It looks like I'm negative 0.5, negative 0.5, positive 3.5. Let's check and see if that's right. Okay. Oh wait, that's 4. Oops. This line is incorrect. Oh, Blue, why don't you do it in pencil? X plus 5, so I have to start at 5. To start at 5 and then go up 1 over 1. So, well, that changes things. So there's my point right there, which would be negative 1, 4. So let's check that in Desmos, and here's where you're going to start saving your Desmos calculators. So those didn't work, we checked them. So I have y equals negative x plus 3. And we have y equals x plus 5. So, where do those lines cross? They cross right here, and that point is negative 1, 4. So that's what we got in our notebook. We got negative 1, 4. So here in Desmos, I'm going to start to keep my checks. So here's my check, so keep that. Okay. All right, now we're going to go into number 12. So here's number 12. Now I could solve this and draw it. So y equals negative 3, y equals negative 1, negative 2, negative 3. So here's my line for y equals negative 3. Here's my line. And here I'm going to solve this. I'm going to have negative 2y equals negative 3x plus 6 divided by negative 2. I have y equals 3/2 x minus 3. Right? Okay, minus 3. Oh, whoa. Is that my point right there? And then 3. 1, 2, 3, 1, 2. So there's my line, and it looks like I cross at 0, negative 3. Looks like I cross at 0, negative 3. So let's check that in Desmos. I'm going to put these two equations into Desmos and see if they cross at 0, negative 3. So I'm going to blank these out. So I can only have to look at mine. X minus 2y equals 6. And y equals negative 3. So let's see where those cross. Right here. 0, negative 3. And that's what we said. 0, negative 3. There it is. I have two of my equations in here, so you should have these two equations in your Desmos calculator. And you should also have number 11, because you did number 11 on your own. Okay. So let's go to number 14. And let's check this one out. 1/4 x plus 3. So I'm going to go up to my 3, my y-intercept. I'm going to do 1/4, so up 1 over 1, 2, 3, 4. Now, positive 1 over positive 4 is the same as negative 1 over negative 4. Negative 1, 1, 2, 3, 4. And what this does is this just helps me check to make sure that I drew a straight line, as long as I can catch every single point. Got a straight line. So here I have 3/4 x plus 5, 4, 5. I got the 5 this time. I was able to count that high. So if I go positive, I'm going to go off. So I'm going to turn both of these negative. So negative 1, 2, 3, negative 1, 2, 3, 4. Well, that's about it. Can't do many more. Okay, so this crosses at negative 1, 2, 3, 4. So negative 4, positive 2. So it crosses at negative 4, 2. So let's check and see if negative 4, 2 satisfies both of these, if that's where they cross. So again, I'm going to head into Desmos calculator. I'm going to do my next equation. I'm going to blank those out. And then I'll do y equals 1/4 x plus 3. Y equals 1/4. 1/4. And you'll get wrong if you put the x down here. 1/4 x plus 3. So make sure you type it in correctly. And then we have y equals 3/4 x. X plus 5. Y equals 3/4 x plus 5. So if we check that, we can see that where the two lines cross the two lines cross right here, which is negative 4, 2, which is what we had. So we just checked our answer, and we have negative 4, 2. Some parentheses around these, negative 4, 2. There's our answer, number 14. So don't forget to do number 13 and number 15. And then when you get that, you're going to want to go up here and you're going to share your graph. So once you have all of your information, all of your graphs on here when you're done with your homework, you share the graph, you copy this link, and you plug that link into your module, 5.1 module. All right. Thank you very much. Have a great day.